Let's first look at a scenario with a primary and secondary. With this, let's say New York City is my primary location. That's my headquarters location. And in New York, I have 7,000 computers. We'll say PCs. Seattle is a branch office. In Seattle, I have 1,000 PCs. And, a handful of servers in each location. But basically, 1,000 records in Seattle and 7,000 records in New York City. Now, each PC, has a user associated with it naturally. Well, you have a few options. Now, let's say I have a single domain. If I have my DNS server only in New York City, that means all the users here, say Bob Ross, every time he logs on, every time he resolves anything by name, he would have to traverse a WAN link and connect all the way to New York City. Each of my 1,000 users would have to do that every time they query anything by name. That's just not a feasible solution. It generates far more traffic than one could actually imagine. To look at how much traffic is generated, I'm going to pull up my command prompt for a moment. The first thing I'm going to do in a command prompt, I'm going to type ipconfig, if I could spell, /flush DNS. This is just going to purge any content that's already in my DNS. Now I'm going to run ipconfig /display DNS. I know we saw these commands earlier, but this will just show me everything in cache. Most of this is related to Microsoft 365, but I have like 4 things showing up in cache. That's it. Well, I'm going to switch to my browser for a moment. Went to my other screen here. In my browser, I'm going to open two websites, CNN.com. Now, I choose news websites because they have a lot of content. And I'll choose Fox News. Pick your poison, if you will. What is fascinating is how much traffic these sites actually generate. If I run my ipconfig /display DNS again, we had 4 things a moment ago. I've only been to those 2 websites. So if I run that command again, ipconfig /display DNS, let's see how much content we have now. A lot. A lot. And it's still scrolling by. And that is only generated from those 2 websites. Now, if you look at these, we have no idea what most of this stuff is. A lot of it is like analytics. These websites are full of ads and other types of things. So you'll just see a lot of stuff shows up there. That's a lot of traffic. So in addition to those types of queries crossing my WAN link, and all the records crossing the WAN link, if I have 7,000 PCs in New York City, every time a computer registers its name and IP address, it creates a record. I don't want that information to be constantly accessed by 1,000 users across the WAN. A solution. Maybe it makes more sense to have a DNS server in Seattle. In New York City, this would be my primary. I'm just going to write PRI. In Seattle, this would be my secondary. The secondary is a read-only copy of all of these records. So here, anytime a record changes in New York City, that change is transferred to my DNS server in Seattle. If you work in the Seattle office, this 192.168.1.25, that is your preferred DNS server address. So you're always going to query this DNS server. You're not going to unnecessarily cross a WAN link to look up a name. So my 1,000 users won't do that. Any query you need to resolve, you will pass to this DNS server. Even those 2 websites I went to, CNN and Fox News, Now, the reason I picked those websites is not because I care about the news, but those are two of the most heavily trafficked websites, those types of websites, like news sites. ESPN is another. When you go to it, it generates a massive, massive amount of traffic. That's why they're often slow to load. Well, imagine if you had 1,000 users go to those sites from Seattle and you didn't have a DNS server. All that would get pushed and pulled across your WAN link. Once I have the server in Seattle, all those queries go here. Now, this will either connect to the internet to resolve it, or it'll pass it back to the primary. But then in Seattle, it's going to cache a copy of it. So the next user that wants that a few seconds later, they'll just read it from the DNS server in Seattle. So the ultimate theory behind this, I call it, we believe it may be more efficient to have changes transfer across the WAN link, individually. If a record changes, it transfers across the WAN link. More efficient than having every user in Seattle cross the WAN link to resolve something in New York City. Naturally, depends on your scenario. If I have 20 users in Seattle, we're probably crossing the WAN link for 20 users versus standing up a dedicated server if you don't already have a server there. So it really is a design issue. We just want to know the characteristics of primary, secondary. Secondary, nothing but a read-only copy that you would put in a branch office. Now let's use the same scenario and we'll talk about a stub zone. In New York City, I have my primary. Now let's say in New York City, this time we have 15,000 computers. So that's at least 15,000 records showing up in my DNS server. And Seattle, we have 1,000 users again. 1,000 users, 1,000 PCs. Instead of having a secondary zone here, which a secondary zone, since it's a read-only copy, it would transfer all 15,000 records, and it would then keep those 15,000 records up to date. So if somebody connected their smartphone or somebody's laptop gets a new IP address, it's going to transfer that record to Seattle and then keep all 15,000 up to date. That can generate a massive amount of traffic itself. So a stub zone would be a happy medium. The way a stub zone works, I will not have a copy of the entire zone. In the stub zone, I will only have records for DNS servers. Now let's pretend in New York City, if we have 15,000 computers, this location's big enough that we're going to have more than one DNS server in New York City. The only thing the stub zone would have in it would be records that list all the DNS servers in New York City. Now, those records are actually called name server. Or NS records is what they're actually named. What happens now? My user in Seattle, they want to resolve something on the other side of the WAN link. They do get directed to this DNS server here, but it doesn't have these 15,000 records on it. Instead, it has a list of DNS servers. It's going to pass that query to one of those DNS servers. The advantage would be, let's say there's 4 DNS servers here. Sometimes that query goes to this one, sometimes this one, sometimes goes to the other 2. So it's truly a way to load balance. So you kind of get the best of both worlds. You don't have a copy of every single record, still have to cross a WAN link to have that resolved. So a happy medium of sorts. Now, one advantage to this, or one more advantage, this does cache the results. So if my user here resolved a file server in New York City, when that gets returned through the DNS server in Seattle, it's going to cache that on the DNS server in Seattle. So if another user wants that same file server, it does not have to go back across the WAN link, if it's still in cache, to actually resolve that name. It'll simply read it from the cache on the DNS server itself. Pretty fascinating. A rule of thumb with a stub zone, you would only configure this stub zone within your company. So we'll say within the same company. Because this type of information, you would never share outside of your environment. And I only say that because we have a solution that's sort of similar, we'll look at momentarily, that you would use if these belong to two different companies. So just within your environment, you would have primary, stub zone, possibly. So within the same company. The last zone type, Active Directory Integrated, which we're just going to call ADI, is what Microsoft always refers to it as. As we said earlier, one big requirement, your DNS servers have to be domain controllers. If they're not, you just cannot host an Active Directory Integrated zone. Won't allow you to create one. So we're going to say my DNS02 in Seattle, that is also a domain controller. DNS01 in New York City, also a domain controller. So they're both domain controllers that now run DNS. Well, now your DNS database, the entire configuration, it actually replicates just like user accounts, computers, groups, all the other Active Directory objects. So if a record gets created here, we'll say new record. That record automatically replicates over here. So they are identical in every way. Unlike the primary secondary, there's no read-only concept. You could create this record on the server in New York City. You could delete it in Seattle, and it would then replicate that deletion. So it is completely bidirectional, the replication itself. They will refer to this as multi-master, meaning there is no hierarchy. One DNS server is not more important than another or more powerful in any way. Any of these can be fully managed. Create, edit, delete records from any of your domain controllers that also have DNS loaded. Some of the advantages to this, it's encrypted. Now that's just a byproduct of replicating with Active Directory. Active Directory replication itself is encrypted. When DNS replicates with it, it becomes encrypted as well. So this would be the most secure type. Perhaps the greatest benefit is something called Secure Dynamic Updates. What Secure Dynamic Updates mean? I can register computers that are joined to my domain. Only computers that are joined to my domain if I choose that option. This is only available with an Active Directory Integrated zone. An example, I have a user, Bob. Bob has a desktop and a laptop that belongs to the company. They're both joined to the domain. So I'm just going to put D for domain join. When these computers power up, the desktop connects to the network, completely authenticates against Active Directory. It will then register itself in that Active Directory Integrated zone. So it's going to have a host A record, name, IP address. Bob powers the laptop up. It connects to the network. It's joined to the domain. So it creates a record for itself as well. Whatever its name is and IP address has a host A record generated. So both of those are registered. Well, Bob also has an iPad. His personal iPad. He connects that to the network. The iPad will get an IP address from your DHCP server. It'll connect to the wireless network, assuming your company allows that. You can surf the internet, you can do all those things, but because your iPad is not joined to the domain, it will never have a host A record created for it. If Bob has, say, an iPhone or Android, like a smartphone, same thing. Connects to the network. It obtains an IP address, so it could surf the internet, connect to resources, but it will never have a record created in DNS itself because it's not joined to your domain. Now, this is an option, the Secure Dynamic Updates. You could choose to register all devices, which would be smartphones, other types of devices, anything that connects to your network that obtains an IP address would register if you allowed all updates. Secure only is only an option with Active Directory Integrated. If you go with the primary zone, you will have to register all devices. So it can't distinguish between who's joined to the domain and who's not joined to the domain. So that's one huge benefit. Cuts down on the clutter in your DNS server itself. Pretty fascinating.